Hello and welcome to this session. So today we are going to be talking about IEEE 802.11 standards, which are basically wireless networking standards, and we are going to look at wireless local area network, and we are also going to look at Wi-Fi. Okay. Now, starting with the wireless local area network, it is basically constructed using wireless technologies and replaces traditional wired local area networks. Okay, and this wireless local area network uses high frequency signals, which could be 2.4 gigahertz or 5 gigahertz. Okay, and when you're talking about IEEE 802.11 standards, we are talking about wireless local area networking standards, which are defined by the Institute of Electrical and Electronics Engineering. Okay, so this is an institution which majorly deals with these kinds of standards. Okay, and when you're talking about Wi-Fi is an alliance formed by a major group of manufacturers and uses Wi-Fi as their logo. And Wi-Fi standards are based on the IEEE.11 standards. Now, when we are talking about wireless local area network, there are some basic terminologies that we need to be aware of, and we are going to go through these terminologies and get to define them and get to know what roles they play in our networks. One, we talk of an access point, which is a point to which a client or a host is connected to in a wireless local area network. And we basically have three types of access points. One, you could have an autonomous access point, which is a standalone device used for home and small office, and is basically less complex when deploying. Okay, we have lightweight access points, which are also referred to as VTPs. These are devices that require a wireless local area network controller, which could be physical or virtual, and communicates changes to these access points. So it basically manages a group of this is an access point that is managed by LAN controller, wireless local area network controller, and basically wireless local area network controller controls a group of these lightweight access points and communicates changes to these access points using couple of tunnels, which stand for control and provisioning of wireless access point tunnels. And the tunnels basically have the capability to encrypt and decrypt data that is in these networks, or is traveling to hosts or through these networks. Okay, we basically now have the last type of access point, which is a cloud access point, whose management is done in the cloud. Okay, so, and the cloud is the latest trend, so these have now started becoming more common. An access controller is a device that is used to manage a group of access points, as we talked earlier, and these basically are lightweight access points or fit APs. Okay, and they use a couple of tunnels, which stand for control and provisioning of wireless access points, and these tunnels basically define how to manage and configure access points in a certain manner. And we also say that they have the capability of encrypting and decrypting data that is going through these networks. Now, another term that we could come through is a basic service set, which refers to an area covered by an access point. The other term that we could come across is a basic service set identifier, which is a LAN identifier, and identifies an access point using MAC address. Okay, we have what we call an SSID, which is an identifier which is represented by a string of characters and is used to refer to an access point. Okay, so SSIDs can replace BSSIDs to help users identify LANs. So BSSID and SSID are basically the same, only that one is understandable to a computer, while the other is understandable to a human. Okay, we have another term which is an extended service set, ESS, and this comes in to solve the problem of limited coverage of an access point or basic service set access points. Okay, remember that basic service set has a limited area coverage, so an ESS or an extended service set basically takes BSSs, a group of BSSs, and makes them look like one, like one access point, such that the client, when moving around a network, they do not note the sense or the change of the service set identifier, which is the character of strings that recognize an access point. Okay, I hope I'm clear on that. Okay, an ESSID is basically a large scale virtual BSS and contains multiple BSSs with the same SSID. So we could call this an extended service set, which is virtual. Okay, so it's basically an ESS which is virtual. Okay, now another term that we could come through is roaming. And roaming refers to when a client changes the access point association. Okay, and we basically have two types of roaming. And when you're talking about changing access point association, this means from moving from one access point to the other. Okay, and we basically have what we call an inter-controller roaming and intra-controller roaming. Intra-controller roaming is roaming between access points which are connected to the same LAN controllers. This we could consider like the way we talk about intranet, which is inside network, and internet, which is external network. Okay, the second type of roaming that we have is an inter-controller roaming. This refers to roaming between access points which are connected to different LAN controllers. Now, when you're talking about a group of controllers that know about each other, this controller controls this network, the other controller is just next to it and controls another network, but they basically know about each other. We call this a mobility group. Okay, these are access controllers that know about each other. Now, when we are talking about IEEE 802.11 wireless networking standards, this basically came as an evolution. It's basically an evolution until the Wi-Fi standard, or the IEEE 802.11 standard that we use today. Today we're in Wi-Fi 6. Okay, that's the latest standard, Wi-Fi standard. But the first standard, which was 802.11, and in this video, just to reduce the redundancy on 802, I'm just going to refer them as .11.11a and so forth. So .11 was released in 1997 and utilizes the 2.4 gigahertz band and has a maximum bandwidth of 1 or 2 megabits per second. .11a was released in 1999 and utilizes the 5 gigahertz band, and the maximum bandwidth is 54 megabits per second. .11b was released in 1999. It utilizes the 2.4 gigahertz band and the maximum bandwidth was 11 megabits per second. There is .11g, which was released in 2003, utilizes the 2.4 gigahertz band, and the maximum bandwidth for the .11g was 54 megabits per second. .11n was released in 2009. It utilizes the 2.4 gigahertz and the 5 gigahertz band, and the maximum bandwidth as of 2009 was 150 megabits per second. The 11AC was released in 2014. It utilizes the 5 gigahertz band, and the maximum bandwidth with the 11AC is 3.5 gigabits per second. Now to the latest, which is .11ax, which was released in 2019. It utilizes the 2.4 and the 5 gigahertz band, and the maximum bandwidth in 11.11ax is 9 gigabits per second. Now let us talk of another concept, which is access point and access controller networking. Now we basically have two networking modes, namely the layer 2 networking and the layer 3 networking when it comes to access point and access controller networking. Now in layer 2 networking, access points are connected to an access controller or a layer 2 the network. Okay, this means that you connect directly to an access controller, or you just connect to a switch, okay, a layer 2 device, and extend the access point, or put the access point wherever you want. And this is most common in is what basically most people do. Okay, features of layer 2 networking: one, it is quick in deployment. Okay, when you are doing APAC connections or networking, you basically the deployment is relatively quick, and it is applicable to simple or temporary networking, not too large. Okay, because if you do too large, then too large networks with this layer 2 networking, then you're basically going to have some issues. Let us come to layer 3 networking. Layer 3 networking in access point access controller networking, one can basically connect an access controller to dozens or even hundreds of access points, which is usually complex. Okay, we are used to when you are you're just connecting to your switch and extending that service point to where you want, or that access point to where you want. But now here you have dozens or even hundreds of access points. Remember, in layer 2 networking, it's recommended that you only have 4 devices, 4 connections. Okay, access point access controller connections, or to layer 2, you're basically advised to have 4, not more than 4. So in layer 3, we can see that the concept of scalability comes in, and when you're configuring layer 3 networking, access, that is access point access controller networking, one needs to configure an access point's IP, its DNS, and its default gateway in order for this layer 3 networking to be efficient. Now let us talk about the 3 most recent IEEE 802.11 standards, which we are going to talk about. We are going to talk about how many users can each standard accommodate, and what is the mode, upload mode, what does it use, and what does it use when downloading. What are the different modes in upload and download? Now, in order to understand this, we need to understand some of these concepts. We have CAM, which stands for quadritive amplitude modulation. This simply refers to the number of different clients that an access point can hold. Okay, when we talk of SU MIMO, this means single user, multiple inputs, multiple outputs. Okay, that is basically self-explanatory. When you're talking about MIMO, we are talking about multiple user, multiple input, multiple output. Now, just to give a small guidance to those who might not have heard these terms before. Single user multiple input multiple output means that there can only be one user, either in upload mode or download mode, performing different tasks. Okay, that is what we mean by multiple input multiple output. Okay, when we talk about multiple users, this means that multiple clients or multiple hosts in a network can do various tasks, okay, in the same network, okay, without interference. Okay, and single user multiple input multiple output was basically in 802.11an, okay, which supported 64 users, okay, and used single user multiple input multiple output on both upload and download modes. Okay, now Wi-Fi 5 could support 256 users at the same time, okay, and you basically could have in upload mode, you could have a single user with multiple input multiple output. That means if you try to upload when you're so many, the 256 of you, you're going to have delays. Okay, you have to wait for one to finish uploading so that the next one can take over. But in download mode, we could have multiple user multiple input multiple output. Okay, this means that all the 256 could be downloading something, okay, and they could be multiple downloads. Okay, now in Wi-Fi 6, this is where we beat all these single user stuff. Okay, in Wi-Fi 6, an access point could hold up to 1024 users. Okay, and in both upload and download modes, the users could have multiple uploads, okay, and multiple downloads at the same time. Okay, so that is basically it when you're talking about the three latest standards and their basic modes of operation, and how many users each Wi-Fi standard or 802.11 standard could hold. Now, what is an advantage of Wi-Fi 6, which is the most recent Wi-Fi standard? It is faster and has better performance with multiple connections. Okay, it has increased the bandwidth by 4 times, okay, and has reduced latency by 20 milliseconds, which is average reduce of latency by 30%. Okay, now also the devices that support Wi-Fi 6 come with low power consumption, so you can basically see the advantage of acquiring or deploying this Wi-Fi 6 model. Okay, and that, I believe, that is basically it when you're talking about IEEE 802.11 standards, wireless local area networks and Wi-Fi. So thank you guys for watching this video. Hope to see you in the next one.